Atomic structure, the nuclear atom. And this really is an introduction to atomic structure. How do the nuclei of atoms differ? The nuclei of atoms contain just protons and neutrons. So, different types of atoms will contain different numbers of the two particles, protons and neutrons. If two atoms contain the same number of protons, then they are atoms of the same element. If two atoms contain the same number of protons but different numbers of neutrons, then they are isotopes of the same element. Atoms contain a positively charged, dense nucleus containing the protons and neutrons, sometimes called nucleons. Negatively charged electrons travel in orbits in the space outside the nucleus. So here are my three subatomic particles: proton, neutron, electron. Protons and neutrons found in the nucleus, they have a significant mass compared with the electrons. They're given a mass of 1 AMU. AMU stands for atomic mass unit. If I were to write down the actual mass of a proton and a neutron, I'd need a differently structured table. There'd be too many zeros after the decimal point. It's just much more convenient to regard them as having a mass of 1. Electrons, conveniently, their mass is so small, even compared with the proton and the neutron, we regard their mass as negligible. P for proton, P for positive. Protons are found in the nucleus with neutrons which are neutral. I think neutrons are aptly named. Electrons travel around the nucleus in orbitals. They are negatively charged. The atomic number is the number of protons in the nucleus of an atom. Mass number, the total number of protons and neutrons in the nucleus of an atom. And I've got this now. We need to use symbols such as X, X representing the symbol of an element. A and Z, atomic number and mass number. A is the mass number, not the atomic number. I could say it's A because it's the atomic mass number. Z is the atomic number. And we can use these two to find the numbers of protons, neutrons, and electrons in atoms and ions. Now, the chemical symbol X with A and Z beside it is exactly how it's written in the course outline, in the syllabus. First symbol, I've got Mg for magnesium, 12/24. This is how it's put together in the data booklet. Confusing until we realize the smaller number is the atomic number, is the number of protons. It could be written with mass number over atomic number, as we've got at the top of the slide. It could be written the other way around, as we have in the data booklet. And if you randomly look up periodic tables in, let's say, Google Images, you'll find both versions. The small number is the atomic number. It's just the number of protons. The mass number is the larger number. It's protons and neutrons. And my number of positive protons will always equal my number of negative electrons in a neutral atom. A magnesium ion. An ion is simply a charged atom. Protons and neutrons stay in the nucleus always. They never leave. They're always there. It's only electrons in the outside energy levels that can get lost or can be gained. In this case, my charge Mg2+, 2 negative electrons must be lost. 10 remain. 2 plus because there's 12 protons and 10 electrons. For Cl, chlorine, smaller number, atomic number 17. Whether I have Cl as the atom or Cl minus as the chloride ion, still 17 protons. Subtraction, 35 minus 17, 18 neutrons. It's only electrons. The number of electrons can change. Cl minus indicating 1 electron had been gained. Phosphorus, numbers. 15, atomic number, the smaller number. 15 protons, no charge. 15 electrons. 31 subtract 15, 16 neutrons. Al, aluminium. 13, my atomic number, 13 protons. 27, my mass number, 27 minus 13, 14 neutrons. 3 negative electrons must have been lost to make the charge 3 plus. And sulfur. Atomic number 16, 16 protons. Charge 2 minus. 2 negative electrons must have been gained to give 18. 32 minus 16, 16 neutrons. Now, what determines the chemical properties of atoms? Atoms have to collide if they are to react. When 2 atoms collide, it's the outer electrons that meet. Therefore, it's the number of outer electrons, together with their attraction for the nucleus, that determines the chemical properties of atoms. The atomic number gives the position of an element in the periodic table. Reason. The atomic number tells us the number of positive protons in the nucleus. For a neutral atom, this is the same as the number of negative electrons in the orbitals. The number of electrons determines the position of an element in the periodic table. Electrons occupy orbitals. We sometimes call them shells. They will always get as close to the nucleus as possible. Only 2 electrons will fit into the innermost shell, 8 will fit into the second shell, and 8 or sometimes 18 will fit into the third shell. The group number, 1 to 18, gives us the number of electrons in the outer shell of any of the first 20 elements. Period number tells us the number of occupied shells. Here we have a number of elements ranging from atomic number 3 to atomic number 20. The atomic number giving us the number of protons in the nucleus. And for a neutral atom, the number of protons always equaling the number of electrons. Given the number of electrons, I can work out the electronic configuration. Innermost shell always full first, then the second shell away from the nucleus, then the third, until those shells are full. When the third shell is full, additional electrons go into the fourth shell. The group an element belongs to is the same as the number of electrons in the outside shell, noting that elements with 6, 7, and 8 electrons in their outermost shell are actually placed in groups 16, 17, and 18. That's an international convention. If I look at oxygen, electronic configuration 2,6, period 2. Sodium, electronic configuration 281, period 3. Calcium, electronic configuration 2882, period 4. The period number corresponds to the number of occupied shells. Each main energy level can hold a maximum of 2 n² electrons, where n is the number of the energy level we're thinking about. The first orbital, n equals 1. 2 times 1 squared, 2 electrons. The second orbital, 2 times 2 squared, 2 times 4 is 8 electrons. The third orbital, 2 times 3 squared, 2 times 9, 18 electrons. The number of electrons in the outer shell gives us the group number an element belongs to. The period number tells us the number of occupied shells. Finally, a few quick questions based on past paper questions I've seen over the years. Which statement is always noting the bold? Always, that's drawing it to our attention. Always correct about the number of subatomic particles in an atom. Please don't look at what's in red. See what you think. And the answer is D. Simply because the question asks about atoms and not ions. Number of protons is the same as the number of electrons. For the other options, for A, number of neutrons plus the number of protons would actually give us the mass number, not the number of electrons. Number of neutrons is always larger than the number of protons, and C, the number of protons is always the same as the number of neutrons. Neither is correct. Both are correct sometimes, but not always. Explain why the relative atomic mass of nickel is smaller than the relative atomic mass of cobalt, when the atomic number of nickel is 28 and that of cobalt is 27. Well, if nickel has atomic number 28, I know its atoms have 28 protons. Cobalt atoms have 27. If the relative atomic mass of cobalt is the larger, it's simply because cobalt atoms have more neutrons. Deduce the number of protons and neutrons in the iron. The atomic number 17 gives away the number of protons immediately. Mass number is the total number of protons and neutrons, 35. Subtract 17 for the protons, I get 18 neutrons. And thirdly, deduce the electronic configuration of this ion. If the ion comes from Cl, atomic number 17, that's 17 protons. 1 electron has been gained, that's 18. 2, 8, 8. Group number and period number. My group number, well, if it came from atomic number 17, 17 protons means 17 electrons, means electronic configuration 2, 8, 7, remembering that means group 17. 3 occupied shells, period 3. That's it. If you found that useful, please hit like and hit subscribe to be notified about more content.